Welcome back. In this lecture, we will put the theory of recursion into practice by implementing a classic recursive problem, calculating the factorial of a number. This will illustrate how the base case and the recursive step work together to solve the problem. 1. Defining the factorial problem. The factorial of a non-negative integer, n, denoted as an exclamation mark, is the product of all positive integers less than or equal to n. The formula is n factorial equals n times n minus 1 factorial. This definition is inherently recursive, which makes it perfect for a recursive function. 2. The base case and recursive step. For the factorial function, the base case is simple. The factorial of 0 or 1 is 1. This is where the recursion stops. The recursive step is the formula itself, the current number multiplied by the factorial of the next smaller number. Three. Tracing the execution. Let's trace factorial of 3. First, factorial of 3 returns 3 times factorial of 2. Next, factorial of 2 returns 2 times factorial of 1. Finally, factorial of 1 hits the base case and returns 1. The results then multiply their way back up. 2 times 1 equals 2, and then 3 times 2 equals 6. The result is 6. To summarize, recursive solutions elegantly map to mathematical definitions like the factorial. They solve a problem by deferring the full calculation until the simplest case, the base case, is reached, then building the result back up. Our next lecture 12.14. Keyword arguments. See you there.